Hey guys, seems like a lot of you are having problem with the PIP2 system. It's actually very simple if you don't memorize what all these acronyms are, like PIP2 or DAG, and actually understand what they mean. PIP2 stands for phosphatidyl inositol bisphosphate, two phosphates basically. It is a membrane phospholipid, nothing else. It's a phospholipid that it is in a membrane. And when you split it, it gives you two products. Now, here's how the whole thing works. Normally, our membranes, we said if I wanted to understand what a membrane is, it has a phospholipid like that. It's a phospholipid bilayer, right? It's a two-layer of phospholipids. And phospholipids are basically what? Phospholipids are, this is a 3-carbon group, which is called glycerol. We have one fatty acid here, one fatty acid here, one phosphate here attached to, in this case, it could be choline, it would be phosphatidylcholine, or it could be inositol, which is basically it's not a sugar, it's a carbohydrate, okay? It's a 6-carbon carbohydrate. So this is what inositol is. And so far we know what a phospholipid is. Now, what happens is we have a ligand here, a receptor here, which is bound to a 7-transmembrane protein, right? And this is our transmembrane protein. And this actually itself is again bound to or coupled to a GQ protein, which is, well, that's why they call it GQ coupled. GQ is a trimeric protein. It has 3 subunits, alpha, beta, and gamma. And this is going to activate a enzyme called phospholipase C. Now, the reason I drew all this out is to explain how this whole system works. In GQ, it could be either, this receptor could be either a receptor for, let's say, vasopressin, or it could be for like epinephrine alpha 1. What happens is once we get a signal here, it's going to activate this transmembrane, which is then going to activate this GQ protein. This GQ protein is it's going to use energy to activate phospholipase C. Phospholipase C is an enzyme that basically cuts right here. So you're going to get two products. One is going to be 2 acyl groups and a glycerol, so it would be DAG or diacyl, 2-acyl glycerol. And the other that it gives you is this, which is going to be inositol triphosphate or IP3. Now, DAG remains, this diacyl glycerol unit right here, 2-acyl and a glycerol, remains in the membrane. But IP3 or inositol, this group right here, actually goes further down and it's soluble into the cytoplasm. And it works on a secondary messenger afterwards. Diacylglycerol, staying in the membrane, activates another enzyme called PKC, or protein kinase C. Means it's going to kinase, or it's going to phosphorylate a bunch of enzymes. IP3 works the same way, or it's going to eventually end up activating the PKC, but it does it differently. It works on a intracellular receptor on the smooth ER, and it's going to cause the smooth ER to release calcium into the cytoplasm. This calcium then activates the PKC. Now, what does PKC do? It takes these enzymes that are not phosphorylated, it's kinasing, so it's phosphorylating something, and they're going to phosphorylate and make these enzymes now with a phosphor group attached to them. So now it's phosphorylated this enzyme. Now, some enzymes are going to be active when they're phosphorylated, and some enzymes are going to be not active, or they're not going to be activated when they're phosphorylated. So it could either turn off or turn on an enzyme based on how it works. So that's how basically this whole system works. It's very simple to understand. So if the question that was mentioned at the USMLE high yield page was, if you block this from attaching to its secondary messenger, which is here in the on the SCR, or the smooth endoplasmic reticulum, what's going to happen? Well, we've already passed the PLC stage, so it can't be the phospholipase C stage, because that's just an enzyme in the membrane. We're going to eventually block PKC from actually activating, and that's what the whole question, I'm assuming, was asking. So this is how it all works. I hope this makes you gives you a little bit of understanding of a whole system. And this is very important because people have seen it multiple times on USMLE. Good luck to you guys.